Well, if you know AutoCAD. Okay, so let's take a look at this. So I'm going to go ahead and go to View, Background Bitmap, Place, and then I'm going to go find right folder. Oh, yeah, I have it in here for right now. I think it's that one. And I'm just going to plop it here. Okay? So I just throw it down. My grids are on right now, so the grids are sort of, overlap my image. So I type in grid, and I say show grids no. And then what I'm going to do is actually move this in a position. Okay? So you don't actually use the move command. You got to do this all by moving it manually. Like I'm going to click there, and I'm going to put that at 0, 0. Now that's sort of where my ground line is. So at that point, I might go to layers. I'm going to make a geo layer. Make it current. And I'm going to draw a line at 0, 0. And then I know it's 11, right? So offset 11. So that's how big it actually, that's where 11 is. There's 11 feet. We can go to units. We can change the feet and inches. Probably go to like 64. So now I need to scale this, okay? So I know that panel there is 11 because I can see it from my section, right? So what I'm going to do at that point is go back to view again, set bitmap, scale. I'm going to pick that point and then go to approximately where the 11 mark is, type in 11 feet, and then click. Okay? So this is now approximately 11. Close enough. So I'll leave that on actually. Leave that there. So now I want to figure out how wide this is. And what you guys should be focused on is not the entire project. You're just picking a module. Okay? Yeah. Just one module. So when we look at a building, it's made up out of a bunch of little pieces. That represents a module that's repeating. In this case, our module is actually maybe this whole setup, but I'm going to take double because I'm going to say, based on what we saw, there's a lot of this happening, which seems to be happening on 2. So every 2 modules. So I'm going to go for 2. So I'm going to take a distance here. So that's about 8 foot 8. That's about 17. I'm going to assume it's about 17 feet. You can see maybe we're a little short. I'm going to work with, maybe it's 17.2, but let's just work with 17. Okay? So again, you don't have to be like, we're not trying to do some type of forensic recreate. We could have scaled this a little bit too big or so I think we don't need to overdo it. So now I know I have a rectangle going on here. So I can draw, in this case, a rectangle. And then maybe I can get rid of these construction lines because in the end, I have this sort of rectangle. Okay? Now again, now I asked you guys, think about parameters, right? So what's our first parameter that we should think about, maybe, or first, second? Like the width of, like how big a module is, okay? What else? Well, how tall? I'm thinking like the basics, width and height. Yeah, basic unit is width and height, right? So this rectangle represents width and height, right? It's sort of like the bounding box of the panel, which is rectangular in this case. Some of you guys might not have rectangular bounding boxes.
But are each of those little, those sub, those are the panels, right?
Those are the panels. Those, but in the end, there's sort of an underlining module,
Okay.
and we're saying it's a double panel wide.
Okay.
So just so we can get those openings and stuff, we want to show two panels. So I know I want to be able to adjust this and have something happen. Okay? So this is where we're going to start going into Grasshopper. I'm going to take this and just turn it all off. And then, since I have this ready, we'll go through little by little. Okay? So when I say I want you guys to draw this, though, I would want you guys to draw this in 2D, so you guys have an understanding so that's divided by 7. Okay, so I can draw a rectangle now and pick node or point and then do an offset, say it's a ½ inch. Okay, and then maybe I'll copy this down here. And then we can do an array. So we need, in this case, 2, 7, 0, or 1. Distance, I'm doing just an array. So I made a quick array of this, right? Like, draw it up so you understand.
You end up with doubles on the top one, the top one?
Yeah, the top one has doubles. Yeah, you don't want that.
Okay, that's fine.
Yeah.
Gotcha.
And I probably maybe would keep just in the end, I might just want the panels, right? So I might put those on their own layer. So spend some time in drawing this to understand what's the realities of the facade. Does that make sense? Because then it's easier to sort of figure out what you're trying to do in Grasshopper. So the one parameter is going to be length of this piece and height, right? So we can do a rectangle, and we want to make the rectangle be the sort of bounding box for the whole project, be sort of driving the whole project. Okay? So what I'm going to do is start to set that up by bringing a rectangle. And I know I want to go vertical. I don't want to work on the ground. So what plane do I need? Hello. What plane do I need to go to to go vertical? What do you guys think? What two axes do I need? Z and X. So I'll do a X, Z plane. And then I'll put my rectangle on the X, Z plane. And then I'm going to grab a number slider. We'll go maybe double what we can do. Okay, so we'll make this 17. Okay, so now we have a rectangle that's matching our drawn rectangle. Okay, that we can now start using up as a setup, so as we start manipulating 11 and 17, which is the width and height, all the insides will change. Okay, so far so good. And this is like if it was a panel. If we're going to start doing the sort of embossed version, we'll do it similarly. The question is like the embossing. it'll be interesting how we do it because we're probably gonna have to boolean something away. Like we're probably gonna have to make the embossing because that's like being stamped, right?
Yeah.
So I think we got to make the male and then subtract it. We can't stamp it, but we can subtract it. So we make almost the negative. But for right now, we'll just go with this so we can see how it works. All right, the next thing I need to do, and we don't need that, is start to look at, we know we might need some edges here. So I'm eventually going to want to extract one edge and then one specific item from that edge, which is going to be a line. And then we'll do that for 2 lines eventually. Well, I can't see it right now, but if I turn this off, yeah, let's delete this now. So that's the vertical line, that's the horizontal line. Okay? So to do that, what I'm going to do is come here to my rectangle, put a B-rep explode or deconstruct B-rep. And what it does, we'll take the rectangle, turn it into a face, a surface, but it's also going to give us the ability of looking at the edges and then the vertices. So now I want a list item. Oop, I don't need that. Let's turn those off. And now I have a left and a right that we have to pick, so I'm going to use a number slider, right? Switch that to integers. Edit that to 3, so 0 through 3, which is gives us 4 sides. And then we can start to see, let's turn this off. So that's the one laying there. And let's turn this to 1, and that's the one going vertical. Okay? So we're just sort of defining the edges of our module. So if I start changing the module, these lines will change. The divisions that we're going to make on it will also stretch, or we can add more divisions. So what I do next is a couple things. I start to I make a new rectangle based off of um, the length and then a sort of division count that I want. Okay? So I know I can get the length of a line, right? So this says we know what that is, right? 11. And we can get 11 from here, but I can do then a division and say I want to divide it into 2 modules. Okay? Now I'm going to grab a number slider. And this is going to give me um, a length that we're going to use for a rectangle. Okay? Which you'll see in a minute. So I'm going to do the same for the other one. Oops. And we need a length, obviously. We can't divide a line by a number. So now if we say we want 7, let's edit that. Like 14. So this one's actually going to be 2. And this one's going to be 7. I can then make a new rectangle. That's basically going to be a distance for both the width and the height. And then I want to use the same point. So now I'm getting a module right here. And as I increase the count, the module size changes. And I think I have 7 and 2. Trying to see what's going on. Got those switched. Got those switched. Okay. There we go. That was a problem. And now we can now it's going that way. Well, something's up with. So what we do next now, so we have this. What we start to look at is the offset, sort of the offset for the inner offset. Okay, and then we can extrude it, and eventually we can array it. Okay, so let's do an offset. So the curve, in this case, the distance. Now we're working in feet, right? So if we put 1, that equals 1 foot. So what we want to do is think about in inches. So how can I get inches? How would I get inches, guys? I want this to turn into inches so I can plug it into there. Right now, if I just plug it in, this will be feet. Divided by 12. Right, so you take a division, plug in that. For B, you set that as 12. You know, you have inches. So if I put 0.5, I get 0.5 inches. Okay? Now you can see it's actually going on the outside. We want it to go on the inside. So we can do a flip curve. Change the direction and then get it going on the inside. So then we can do a surface. And then we can do an extrude. Which way do we want to extrude? Y, right? And then we can give it a thickness for the panel. Oh, grab both of these. Yep. Yes? So now if I come here and change this stuff, in the width, the height, it's all going to change. So now all I need to do is an array, and what we can use is this array box. Or box array. So we want to array the geometry. Okay. We want so many in the x, so many in the y, so many in the z. Well, z is how many do we want in the z? 7. So we want to use the same sliders. Okay. How many do we want in the y? How many do we want in the y? 1 is the right one. Did someone say 11? 1. Y is this direction, right? Y is in green. So we want at least 1. And then in 2, how many do we want in 2? 2, right? Because we divided it into 2. And then it's looking for the 3D box array cell. So what that is actually is going to be our rectangle before we offset it. So we made like a box within a box, offset it, and then used all the boxes. So now if I come here and start changing sizes or divisions, it's going to divide. Now, many ways of doing this. Too many probably ways. Too many ways. But I like the idea, and I'm pretty confident, because I've been doing this for a while, that anytime you can just dumb it down to like a simple enclosure and say, I have this, but inside this it's going to be whatever craziness. And maybe at some point it actually needs to go beyond to tie into something else. Or it trims perfectly at that. So you got to find where the repetition is. For some of these, it's real simple. The repetition is a reveal line. But other ones, it's patterns, layered of patterns, right? So you have to find out where that happens. Where is, and typically, from what everything you're going to find, because it's maybe they're big buildings, there is a repetition, even if it's well hidden. We're trying to be well hidden. Okay. All right, let's look at the trickier parts now. I'll probably pause. Because what you guys will have due for, we have midterms. Oh, let me pause. All right, so let's look at, so we have sort of the basic panel. When we saw this last time, oh, so let's think about like getting this thing doing this, right? So um, I'm gonna go to a side elevation, and I'm gonna go ahead and maybe just make a real simple line. I mean, I could bring the elevation and trace it. Trace it. Maybe we should do that. We have it. Have it in here. All right. So it's this elevation right here. Oh, come on. Okay. So I don't want the whole thing. Something's wrong with my button. So let's just take a crop. Computer's working slow today. And my key tool's not working. And then we know this is 11, right? So let's just make sure, offset 11. Let's make the line. So we know floor to floor is 11, right? So let's go ahead and move this. Then we'll scale it. So we know up there, we say 11. So there it is, right? And now we're going to draw this so we have the two panels. Does that make sense? So we have these. Okay. So I'm going to draw a line. And again, I don't have to be super accurate, but we know you can take a distance here. Figure out approximately. It looks like it's offset at 3 feet. See if that's close. Yeah, that's close enough. Maybe it's a little less. 2'10". And then we'll just grab intersection to intersection. That looks pretty good. We'll extend that up. (5'6", maybe. Okay. Now we can just do a fillet. This is like AutoCAD, right? Radius. Let's try 1. Let's try actually 4. Nope, even bigger. Let's try 10. Okay. Sort of need to split that there. So let's fill it. Alright, so I'll go into the 3D view now. So that's sort of my side profiles. Now I know this is one of them, and from what I can see on the elevation, I mean, yeah, it's also doing that. Hey, if we're gonna do this, right? Be real about it. But it's basically 1, 2, 3, 4, 5, 6, 7. Okay. And we'll get this. This is an easy thing to do. This little cut. We have to redraw it. So let's not worry about that right now. Let's just do 1, 2, 3, 4, 5. Okay, for the inside one. So we know it was 5 times. Each of these was 8.5, right? So we need, oops, 5 times 8.5, 42.5 feet. So we're going to extrude that line 45.5, right?
42 and a half.
Did I say 42?
Yeah.
Let's go negative. Okay. Then we can do the other one later, but let's try to get this thing matched on here. And the tricky part is right here, right? So we want this thing to now to be mapped onto this surface. So what I want to do is I didn't create this surface in here, but I can. So let's do that. I'm going to go ahead and reference that curve. Okay, so that curve is now referenced. And now I can do the extrusion part, yeah? So I can do an extrude. What direction do I want to extrude? Good. And we want then, we can do a, yep. So we can actually plug in a number here, 42.5, but let's put a slider on here. This will be another, let's go all the way to maybe not 100. We'll set this to 42.5. Okay. And now the technique I'm going to attempt to use is going to be which we probably got to do a few things to this to dumb this down. And what I mean by that is we probably shouldn't be using all of this lines, but we should be going, like 11 up, 11 down. Does that make sense? And trimming it. So at least our length is floor to ceiling 11. Does that make sense? So we have the right module, the right length. So we're terminating it properly. So I'm going to do an offset 11. So I have this line here. I'm just going to offset these. So we need to extend these a little bit. Okay. And then we got to look at the ones down here. Is that 11? Maybe the building gets shorter right there. Seems like the building gets shorter, but let's assume it doesn't get shorter. So we'll trim it. Okay. So now we know this thing is broken up into 1, 2, 3, 4, 5, 6. Okay? Okay, so what we need to do now is we'll try a couple things. We need to divide the surface to match these guys. Okay? Does that make sense? We need to divide the surface to match the proportions of our division this way. So this way we have it correct. This way we also have it correct. So there is what's called, and a lot of these things you guys won't know, but when I see your work, I can say you need this, this, and this. I mean, what's going to happen on Friday is everybody's going to have a very different approach. I mean, I'm just showing you one approach here. This might not work for anybody in this class, except for maybe one or two. But it's a thought. It's the way you think, right? So the concept is the same, you know, especially if your thing is doing something. So we need to do a divide domain. What a divide domain does is take a surface and then divide it into u's and v's, which means x and y. So it subdivides it into x and y's. Okay? So we know we have 1, 2, 3, 4, 5, 6, right? And then we have was it?
I think it's a fine.
So we should probably go with an even number. We can do it. So let's change the extrusion on this. So the extrusion will be 34 then. Because that's 17 times 2. Does that make sense, guys? 34, not 24. So we have 2 in this direction then. So that's just, those are sort of independent. So let's go like till 10. This one we have 2. So that'll be in the x and then in the y. So u is x, v is y. We're going to have 6, we said, right? Now we're not going to see anything happen. There's no way, we'll eventually see this. So that's the first thing. The next thing we need to do is a surface box. Or what do they call it? Yeah, surf box. What a surf box does is it puts a box onto the surface that follows the curvature. So basically just panelize that. See that, guys? So far, so good? Now, we also have a height. So our height probably wants to be the same as our extrusion right now of our panel. So we can probably plug that one in, which is that. Oop, not that, sorry, that. So that way if we make our panel thicker, our extrusion gets thicker. Does that make sense? Okay, so that's our box. So now we have a box here. Now we have to go get this and put a box around that one. So it's all about box on box on box so far. You guys getting this? Rectangle, rectangle within rectangle, and now we're taking another rectangle that's like oriented a certain way onto the piece. Okay, everybody following this? So now we're going to get a bounding box. And what a bounding box does, and we want it to be union box. If I put this in there, it makes a single box around the entire piece. Okay? So far, so good? So now we have our S box, we have a bounding box, we have our geometry. What we're going to do next is a box. I think we do a box morph, reference box, target box. We're going to do a box morph where we're going to take the geometry, our reference box, and then send it to our target. Now there's a couple things that are happening. We'll fix this. At least we'll try to fix this. Something is going wrong with... Hold on. Let's try a different... No, it should be bounding box. And it's probably the data. So we have one box there. You have to look at the lists. Yeah, they're coming out. Just gonna Alright, so let's get rid of that array. I assume it's the array box that's throwing it off. So what we're going to do is a move. So there's the move, and we need to do 7 of those, and we need to go in the Z direction, right? But we want a series of numbers, which means we want a series based on the width of that panel, right? So what we can do is produce a series of numbers. There's the start, and then there's the step size, and then there's the count. So what's a series of numbers? 0, 1, 2, 3. So if my count was 1 and I need 10, it would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So my start, we'll leave it at 0 right now. We can, so we have that in the same. I'm going to plug this into here anyways, and you can see it doing something. But now we need what the step size is. Our step size we did by division to figure out our rectangle. So this was for the height. Here we took 7 and divided it by the length, and this is our step size. So we're going to plug that in for our step size. And then our count was 7. So you want to make sure these things are all linked together. So there's our array, our sort of, our low-tech array. So let's try this now, just to see. Okay, this looks promising. Looks like it's doing it. Doing something. Alright, looks like it's doing it now. Although it looked like there was some funkiness going on up here. It's like running on an angle. Alright, we'll figure that out. Ah, interesting. Trying to think why it's not extruding now. I mean, it's doing it, but something must be going on there. Ah, no, it should be right. Yeah, weird. I don't know. Okay, we'll take a look. Let's turn this off for right now. Alright, let's do the other. So let's do the other move now. So now we're gonna take this and do another move. So it's definitely it was that array. That array was screwing it up. It's working now, but there's still something else going on. And now we want to go into the X, right? And that distance is, um, in this case, we don't have, there's just two. So we could make the argument we don't need a series, but we use a series anyways in case we increase it. So I'll grab another series. And in this case, the count we have, um, and we want these to not only go this way, this has to be like one big move. So let's grab a B rep. Still didn't do it. Yeah, let's not do a series for that one. Let's just use the two. So we know the number count for that is this one. Okay. We change the thickness to 2 inches. Alright, now we can take this and do a bounding box. So um, we have this set, right? And we have this set. So let's put those together in a B rep. So a B rep is basically a combination of surfaces. So we'll put them into one. And then we'll put a bounding box around that. And that's going to be union box, so it's one box. And then we'll plug that in for G, and then this in for reference box. Okay, we're almost there. For some reason it's deciding to. So the reason why we're getting this weirdness is the way the list is working. So let's take a look at this. So right now we have 14 boxes, right? And then we have one big box. And what we're saying is take this geometry, take these boxes which are 14, but here we just have 80, we have 84 twisted boxes. So we need to change that. So let's look at our, so our division was 2, 6. Yeah, it still has a hard time. So we have a total of 12. Let's do a cross reference. I think we figured out, well, I figured out how to break Grasshopper. This was never a problem. I think this morph box on this version is not working. Maybe I should load it on the computer. And I bet you it might work. You know how like things weren't working last week on yours, but it was working on mine? So yeah, unfortunately this stuff, it's in beta, so it means there are errors. But this should be panelizing and getting this on here. Somehow it's having a hard time with dealing with maybe multiples. this happen? Alright, let me pause this. And what we'll do is make sure we put a so let's try to join this. Well, we're getting closer. It still might have a problem. So let's not do a join. Let's try a... So we have a solid union command. Yeah, it's still not showing it as. Yeah, this is going to be the problem when we're dealing with sort of paneled systems. So it's going to be better. Unfortunately, we like although we made this little array here, this panel, we can almost ignore it because in the end the module is not the big panel. And this is because what we're trying to do with this sort of curving. Um, so what we can do in the end is take the single panel, and I'll show you what I mean in a minute. So we got the offset. So now we have just a single panel. And then our boxes is going to be, we extrude our curve, but our count, in this case, our U count, is going to be the same count that we divided that by, times 4, because we want 2. But just do 2 panels across because they made them bigger anyways. And then this will be 7 times 6. So you see how we get these boxes now? Now we should be able, by no-brainer, be able to map that to there. So now these are mapped. But the only issue now, so the tricky part now is we actually lose the reveal the way it's mapped because we're taking the box. So our bounding box is going to have to be driven by an extruded offset. So before we offset, we're going to extrude that as well. And you guys will understand this hopefully in a minute. So this is so now we should have a little height seam drawing. Let's see. Let's turn this all off. Let's increase the offset to 2 so it's really visible. Okay, got that, but it's having a hard time with the height now. Well, I would say there's a couple things. I think definitely something's up with the morph box. Because now it's working. It's like working in this direction, but not in the direction. So it could be the orientation too, of that we're vertical, guys. I know it sounds odd. We spent all this time making this vertical. So let's go ahead and put this down horizontal again. So that's pretty easy to do. We can just come here and switch the XZ to XY. And then I'm going to switch that. And then we got to flip the elevate the Y to a Z. That did it. That was the problem. That was the problem.
You have to wait now.
Yeah, for some reason it looks like it's... Yeah, this is getting stretched. That's why. That makes sense. So the reason why, remember we spent all this time doing this vertically. If we did it flat, I think it would have performed the way we thought it maybe should have performed. Now we need to increase. So if we increase this to 4, which is let's do multiplication. So now we have all the panel size and with the offset. So it had to do with it laying flat. versus being vertical. So it was all to do with the bounding box, I think. Okay, well this is working. The question now is, can we try like what we did before? We'll test it out. But you can see now, if we come here, so say I change my count. I don't have it all linked together, so I gotta link it. So that is linked. So well, I can increase the width of the extrusion of the panel, and that increases. So we have the ability to manipulate the width of that. Where it gets trickier now is, like, you know how we have in their elevation the cutout, the crop? Like, we would have to do like a Boolean command and cut that out. So if I went into like a, in this case, a front view, and I'm just going to draw an angle. So say there's some type of cut. We could take that curve and set it into here. And then we can take an extrusion. And then we're going to take a so we can take like that piece, and then if we use a solid difference, we can take the final product minus that product, and in this case it's missing those, I guess, but you see how it cuts those out. Let me try a surf there. Yeah, it's funny, it has a hard time dealing with things that don't cut it. For some reason, because these aren't being hit, it's not cutting this away, which is bizarre. But you can see how you might be able to get in Grasshopper like some type of trim line. Again, the software isn't perfect. It obviously has some glitches. We've run into many. But for you guys, I think you just have to try to figure out what is that. What is your range? Yeah, like what is this? What is the sort of piece, the module that's repeating to sort of produce that, similar pattern that looks like it might look like it's an infinite pattern, right? But there is some type of repetition. And I think for next week, I would like to see where you guys are at by printing out. Like, print out the one you just drew, like 2D, which could be complex. I mean, this is not that complex. And then print out the version that has a parameter that you're changing, and maybe show us two states of that parameter. It being taller, shorter, deeper, more holes, less holes. Does that make sense? And another thing is, yeah, have your definitions here, so we can. rather than us maybe printing and pinning up, let's just, we'll do it by projection. Okay? That way, just have them on your computer. I can take over your computer and throw up the PDF. We can look at it, and then we can look at your definition and see where you're having problems. Okay? So the goal is to go through everybody's and just knock them out, and that everybody fully understands what's going on. Does that make sense? So what problems are you guys having? Like I can take over your screens. And you see, this stuff does take trial and error. Sometimes things don't work even when they should. Um, but I think for what you guys are doing, it could be really, really, really simple. I'm trying to apply this to a whole facade, you don't need to do that. Just focus on the crop, yeah? Don't try to do the whole building. Just do one floor, floor to floor, and maybe 2 modules, 1 module, not very much, yeah? Limited. Keep it simple. I think the biggest problem sometimes people have, they decide like they're gonna, model everything. No, you start with very basic and understand the very basic, and then get into the real complex stuff. Yes? Questions? You had Eddie, you had a question? Can't get things to meet. Yeah, it sounds like my problem right now. Whoa. Right, let me plug back in. Oh. Alright, let's see. Whoa. You guys haven't done any work anyways. What do you mean? 15? I'll take a look at it. Let's throw them up. Let's look at it. You got something on there? Yeah, a lot of it's just a screen. So you want to stay this one? Or? I gotta get a gist of what's going on. Hold on. So when you try and join these two, you do the Boolean, union, and it's, what does it say? Yeah. Oh, it might be. Yeah. Service closed. Well, sometimes they just don't. They don't like each other.
I think it's because of the fact that I had trouble. I couldn't do it properly. You finally make it easy. I tried doing select that object.
Yeah, the other thing to do is union.
I couldn't do a drawing
Yeah, what you could do, um, what you could do is, many ways to skin a cat. Did you say this is here? Yeah, I can mess this thing up.
Oh, I even tried doing it slowly.
Yeah, I'm gonna try to.
I couldn't even get the extrusion from the top spiral, but extruded from the outer surface. Couldn't even draw it once I extruded. Why don't you join me?
Try to trim it. I'm gonna try to put a surface from the red onto the blue. So I just trim this. Oops, I want to trim it again.
I'll try trimming both.
So I trimmed it. So now I'm gonna trim this off from this, and then make a solid so they both meet in the exact same spot. Then I'm gonna try to do it. Yeah.
Yeah, I was trying to do splits and
So let's try. Although I think I gotta trim out. Hold on, I need to trim out the center part. How's your roommate doing?
she got out yesterday,
Oh, nice.
last night,
Out of prison or out of the mental institution?
out of the mental institution.
Yeah.
But she's still mad at the world. She only went in because she wanted to work on the fact that she lost her 2 part-time jobs in the last week. That her job.
Okay.
But she's still mad.
It's alright, it's okay to be mad.
And like her 2 part-time jobs are
I want to try to trim out the other surface of the intersection.
Yeah, I wanted to cut one out of the other, but then somehow I lost my cap on the red one,
Uh-huh.
so I put a planer and put 3 trade in the cap, using my new cap. All of it.
Why don't you want to trim? Trim! Let me explode this thing. Okay.
Oh, you created the duplicate?
Yeah.
And I tried moving the spiral down into it further because of that, they were saying it wasn't intersecting.
Yeah.
I think it's complaining about the intersection because it was such a gradual
Right, this should.
incline when it meets, I think, one is just having issues. Like these are too close together.
So what I'm.
Too tangent.
So basically, I'm trying to make a new solid out. So let's see a little. Okay. thing happening here, which will do. So if I pick these two, I can say solid. Create solid. Keep a fingers crossed. I don't know what create solid. I can try to join them. And it's, yeah, it's closed. Alright, now let's try to union. But not this now, I gotta move it over here. So I need to pick this. Do it. And you save this, yeah? Okay, so that and that is now sitting in the exact same spot. Keep your fingers crossed. So the next, I know what the next trick is. Yeah, so the next trick is, we could have just done it there, but what I'm going to do now is trim out and just try to rejoin it. Like I'm basically doing what Boolean Union does manually. I don't know if that makes any sense.
Yeah.
So I'm going to take this now and
I had to do similar things where,
this one.
like when I couldn't get the cat command to work, so I created a plane, threw the plane in, and then told it to slice, then
Mhm.
split it, and then delete the extraneous parts and then join the slice. Stuff like that. And that's what allowed me to create that solid join.
So let's try to trim off the center.
Is it not allowing it because it's, is that
Sure.
still exploded?
Well, what I'm gonna do is project this to the surface. So I'm gonna project it. And delete input, yes. Project it to there. So now I know it's on there. What is this? I have an idea why they're going trim. Let me just explode it.
That did something.
Yeah, you gotta explode it sometimes. That's the one from the bottom. Okay. So now we can. So the idea is I'm gonna turn the other one, get rid of the bottom of the other one, and then try to join it up. Does that make sense?
Yeah, two open surfaces and
Yeah. So. Put this over. Explode this. Get rid of that. And then we just gotta pray there's a touch it. Rejoin that. Show. So as long as these are touching, I'm gonna join these first. So this is an open poly. This is an open poly, of course. We're gonna take these. We're gonna say join, and we have a closed poly that has a hole in it. How is that possible?
where did that come from?
Or is it? It can't be physically possible because there's not a hole there. Be the normals are messed up.
Or did we lose part of it at one point?
Yeah, it's done.
Because if you look at it from the side,
No, it's done.
is there?
That surface is done.
Or is it?
It's exploded again. You know, you always gotta trick things. So if we explode it,
Oh, and then reselect all.
Well, we're gonna take. Want that. Let's join it to that. See if it goes away. No, it didn't go away. It's still there. Right? Yeah. So let's try this again. Let's hide that. Join that. Show. Join. Oh, that's a solid, my friend. A lot of work, huh? Yeah, so that's what basically is happening with the Boolean command. It's like doing it manually. Supposedly there's no naked edges, so
Well, yeah.
it says closed. So usually when it says closed,
Yeah.
it's closed. We can analyze it and look for show edges. And we just want naked edges.
Nothing selected.
Yeah,
I think the fold below, because you had to break it down into steps, and I think the fold below, grab this, join.
too
It
much
was
for
just,
it.
Yeah, it was blowing up. Too much to calculate.
Yep.
But, be nice, good stuff.
Too complex.
Too complex.
Complexity
not
is
just
beyond.
failed.
Complexity is beyond. Because it's doing what I'm doing manually. I mean automated.
Yeah.
It's not magic.
Again,
It's just looking for surfaces,
Yeah.
trimming them, trimming the openings out, trying to figure out where but it's doing it through a script. It's not like there's
and
no.
at some point, it's probably one part of the script is taking too long, so the whole script will.
Yeah, or they can't tell what's inside up versus outside.
Okay.
Yeah, trust me, I've spent hours on this. Who else wants to show some? Joe?
Well, I did want to do something like this. I heard it.
Yeah.
This is between the line.
Yeah.
Nice
Just a
to
bunch
do.
of metal screws.
And you have a
Is it
nice-
pretty flat? Or?
and you have a roof in front of the building, the actual building. It's a much bigger scale than I thought.
Yeah.
I'm thinking like these are one foot. It's much bigger. They're probably 3 inches, I think they're probably 30 inches, 24 inches. I got a scale.
Okay. Good work. Are you trying to make these up there?
Potentially, yeah, so I was just kind of sketching out, like, maybe, I mean, the system was fun.
Yeah, so some of this, you can show this stuff, show this next week.
Means I had it, so I don't know.
I should try to show you how to do these at the same time. To do that as a, that would work with it as what we were doing now. Maybe that was a bad spot. And then we can, I'm going to use, what's it called? Yeah. So I'm going to bring it up on the screen now to show you some things. Yeah. Okay. Okay. Have you found, is there a repeating pattern in there yet, or have you found a good elevation? Find a good elevation and draw it up and see if you can find a repeating pattern. It might not, because it's not that big of a facade. And then you can think about the panels. But I would figure out what the chunk is, like don't do the entire thing. Do like a piece of it, you know? Does that make sense? Or?
Yeah, I mean, we figured out the pattern.
Yeah. Yeah. Yeah, I want to show, Josh, maybe I can use just your computer. Need 106. We need this times 2, actually. So that would be 173.2. So this is actually going to be 173.2. Oh, can't go that high. Okay. And then our offset's going to be 2 of that. So this, we got to divide that. So we need division. That by 2. Okay. And now let's verify all of this. I'm going to get rid of this. I'm going to take this. Looks like something is off. So we're going to say that's the center. Where did those points go? Can I make a divide by 2? Where did I divide by 2? Yeah. Okay, this number is too big. Oh yeah, sorry. There we go. So there's the center there, and there's the center there. Oh, hold on. Turn these off. Okay, so there's a center, there's a center, there's a center. You guys see this? So now what I'll do is put a polygon at that center. And then our sides, I think by default is 6. So then it wants a radius, which will probably be the half for now, just to see them. And then I want, I'm actually going to get a point collect, let me get all the points. So there's my beginning. So now if I change the size here, let's make it like, that's 20, we can see the size. If I increase the count, that's going that way. And now I want to increase the count going the other way. Ouch. So we also need another series. Josh, are you following this at least? Or? No, I'll give it to you. You could have a separate count. Oh. No, no. Well, let me separate my spaghetti. Alright, so we have okay, we have that. Yeah, this is the trick part because we need to move it over and up and then over and up. So the series becomes problematic. So we almost want to series it after. So let me go back. This spot. Because in this space we can increase it. Basically want to take, we could take potentially these 2 points and then, you know, move them over. Which is going to be, let's try that. Which is a copy move, you know. In this case, this will be x, and this will be a multiply of 2 times Okay. And in this case, there we could potentially make a series. But then we have to it doesn't do it for all of them, so it's like want. So we need to cross-reference the data. So now we can put so by default the count is to 10. So let's just put the same well, we'll do a division here because that's actually it's times 2. So they were doing 8, but we're really multiplying it times 2. So we'll do a division. So we get a square. More of a square portion, okay? And then we can take our final points, plug them into there. Okay, so there's our rectangles, and then our size is a radius. Let's not worry about the size right now, because what I'm going to do is I'm going to make what's called an attractor. Okay, so you see how we can adjust the size, guys. This is a good one if you want to pay attention. So we're trying to replicate this effect, right, of like going small to big. So if we look at this definition, what we've done is made we just took one point basically down here and then made this array to mimic the geometry that it's trying to get, right? And then in the end we have a bunch of points that are arrayed, and then we're placing a polygon at each of those points, centered on those points. I know it's a little hard to see here.
So, you did something very, proportional.
Yeah.
Can you do something random, or?
Yeah, well watch this now. I'm gonna make a point. Okay. I'm gonna put this point in here. I'm gonna set this one point. And then what I'm going to do is I'm going to take all the points I have, which are here, and then that point, and I'm going to get a distance from this point to all of those points. To visually see this, and let me cross-reference this. So now you can use this tractor point. I got to figure out the curve part maybe where it pushes and pulls your. I figured out. I've never done a curve, but it can't be that curve. Yeah, so that's why don't crash your computer. Just do a small little part. We don't need the whole building right now. Yeah. Yeah. Don't do the whole building. Too much. But yeah, it's looking really good. Alright, make sure you guys save your work. have like have clear questions. You know, then we can, you know, if we start at 12, we can probably get through everybody. How many? There's like normally 13, 14, probably
If,
14. Say it one more time. No, we're doing not even walls. We're doing just 2 panels maximum. Okay? So if we're looking at that hotel, be like 2 panels. That's it. Floor to ceiling. Okay? Don't overdo it. You guys can't get the whole 2 panels done if you're going like trying to do it over. Just get 2 panels and then we'll push forward. Okay? No. That, yeah, there's not much happening. That was from, who did that originally? Isn't that Jennifer, who is it? Like superstar now? They're very similar. What does it look like? Yeah. So just wait, draw it first. Guys, just start by drawing in 2D, okay? Go back. Go back. Go back. Send me, if you have problems, send me an email, okay? No, I just took a picture of it. Yeah, maybe I gotta get, my iPhone is so full, like, of stuff. Like the lens, where the lens is, it's full of crud.
Oh, inside the glass?
Yeah.
That's a problem.
Okay.
So I just need to figure out the problem.
Just, yeah, figure out where's the repeating going.
That's why they say you never go to those color marathons.
Yeah,
How big?
not with your phone it is.
How tall?
Floor to floor. Or how tall it really is.
Yeah.
Okay. I assume you can probably blow it out, or there must be a technique.
Compressed
Or,
air.
I got like,
Dust inside an
huh?
area.
Put it in water.
No,
Dump
one
it.
thing I couldn't, my phone wasn't charging, I went into Apple.
Yeah, they cleaned it out and like
Oh
a
my
little,
God, it was like
a little animal
earwax,
came out.
man. Yeah, I was like, what the?
Little dude crawled out.
Yeah, yeah, I'm like, who would have thought that?
I should bring this and go, hey guys, you know, I'll make it real clean. You know, so.
Well, no,
What's up with that, man? That's bad design. You guys get a class action lawsuit going or something? What are they gonna say?
Oh, I think we need the phone, that's what they said.
Really? It sounds like it's a bad design. How about I get a class action involved? Do you guys have a class action on that one yet? No? All right, I'm gonna talk to John. I'll just say Don Johnson. It'll be like. All right, see you. See you.
Oh.
Guys, don't forget your food. All right, guys, do some work. Yeah.
I'll get it the next day, then it's like, trying to remember what John said. It's like too much. I put a lot of effort.
Yeah, you guys should make it. March 17th?
I've been looking at those,
I'm waiting, I just gotta do it.
So is he gonna pick one and like say we do it together, or how's he gonna do it? Because all of them aren't that good. Yeah.
I mean, Josh, or no,
Yeah.
I haven't talked to Steve. 'Cause I was over here sketching
It's
it,
probably
and I seen
working
it
out.
sign on it, I don't know.
Alright. Okay, do some work.
Yeah. He's pretty quiet about it all. I mean, he likes, I think he's okay with design. He didn't like my concept. He didn't like it. Put together like.
Oh, it's
my
alright, this is
PowerPoint
only
was
time I'm taking, I'm working on this model every day next
City.
week.
I said, look, Chicago is his first biennial, you gotta take that into
Solid art
consideration.
and construction.
You know, that's why I looked at it, it's the lakefront, it's the
So,
windy city, so I think, I
yeah.
want this thing to be like
I-
wind, and then I said,
I
you know,
email, like,
and a view, I mean, a lot of people come to Chicago, they're like, wow, what a lakefront. Where else in America do you have this Riviera? I mean, as messed up as our city is,
I had to give myself a deadline, 'cause I'm
There's
just.
a couple of messed up things though that need to happen. Like, how about get this Lakeshore Drive under, like, covered or whatever, like not everywhere, but there should be big swatches, like where the
Trying to
beaches
get
are.
into shit, man.
And just have like a mound or something
over like.
Bury it, whatever, I don't
You mean to
know.
walk, to get to the beach, you mean?
Just so you don't freaking see it or hear it. It's just stupid as step.
Yeah, no.
They should have grown that, it should have been like at Clark, or, you know what I mean? It
Yeah.
should have been in.
Well, I didn't think about that,
You
that's
know,
part,
it's
yeah.
got a brain. Whatever it's like.
But they're messed enough for lakefront.
So I'm like, so in other words, I'm broker now than I was before.
I haven't
Like,
seen,
you know,
I haven't gone to it, I've seen it.
So cheap.
Yeah.
It's just so carnival barbecue, I mean, it's just cheap.
It just looks bad.
And then, and then,
Lakeshore
and I don't
Drive.
like the Lucas Museum, I hope they don't do it. I don't like it.
Wow.
Yep, it's all going to
Yeah,
portfolio,
it's a big
but
mound,
resumes,
space,
yeah.
spaceship's not a big mound or whatever.
Yeah, it'd be good for the city though.
You know,
Get a lot of
I gotta eat, you know, man.
tourists.
No, I mean, just a different design. I don't like the design.
Yeah, it looks a little weird.
I mean, I'm not a big,
Nah.
I'm not
Stick
big
your head
into,
out. How they
like,
gonna do
overly
it?
planned
No.
conventions.
You're right.
But let them
Oh,
know
it's
that you're-
Georgian house, you
You're
can't
right.
put up anything like that.
Cause I'm the
Well,
end.
I own a piece of land,
Yeah.
but kinda like,
You're
it just kinda looks like, like a mushroom, you know, like
Yeah,
got fungus
it's a
on
lot.
it.
No, I need to start
You
doing
know?
that, man, because
I think it would have been that more, I think the mistake of it being, it's a being amount, it should have been like an egg or something.
Yeah, maybe it's right, maybe
Like
that kinda
something.
like smushy kinda thing just doesn't,
Doesn't really work.
yeah, I didn't
Don't
like
work
it.
that.
Yeah,
It's like a mound.
Yeah,
Right. I know,
Sure, it
man.
won't be cheap.
Steve said he saw the plan,
Yeah.
he said it's an inverted Guggen,
Inverted Guggenheim, yeah.
You're talking,
ramped up, you know.
yeah, it seems like it.
How's it going, John?
Good, good, man.
I inverted the goddamn
How's the
Guggenheim
little
first.
girl?
Good. They're both. I have two girls. Two. Is it little or two little girls?
How your little girl?
Little girls. Yeah, real good. Growing.
Was that like 4 and 2?
4 and 2. Yeah, man. They come big.
Next week, thanks.
All right. See you.
So you think it's
Oh yeah, it's fully charged. Okay. Give me your telephone. Oh, she can maybe text her. Oh, sorry. It's not here.
The stiff guy? This is what you meant, huh? Like the way how you
Yeah, I might like progress.